Hi, I'm here today to talk about 3D printing aids for use in the classroom. Um, One thing I've created is a model of the Earth. It comes with both hemispheres and they can be hand painted to look like the actual globe. And then on the inside, it comes apart into the core, the outer core, the mantle, and the crust. So all those layers will illustrate the layers of the Earth. Another thing I've done is to illustrate the glucose uptake cycle. This is a 3D printed lesson in biology. It represents the glucose uptake cycle in the cell. We have the insulin receptor, the glucose gate, a glucose molecule, and an insulin molecule. So when the cell needs additional sugar, and the sugar is high in the bloodstream, the body releases insulin, which attaches to the receptor. That signals the glucose gate to open, and then it's able to take up the glucose molecule. Now, a virus or anything else wanting to invade a cell will not fit through the glucose gate, and that's how the cell ensures that it only takes in the sugars that it needs as the gate opens and closes and allows only a single glucose molecule to pass through. This is for chemistry. It's a molecule building set. This is a commercial product, and it's available, but it has been augmented with some 3D printed parts. So if your set doesn't come with enough molecules to build what you want, you can 3D print yourself the rest. This would represent a carbon dioxide molecule. So the double bonds have been 3D printed, the extra oxygens have been 3D printed, and you can choose your colors. And this is the size for individual use for an individual student, and there are also available the double size models in 3D printing. I have not seen this commercially available, so this would all be produced for the teacher on the 3D printer, but it's much larger and more easily visible from the front of a classroom. So this is the model set that I've developed for assembling an atomic nucleus. The purple are protons. They have pegs sticking out. You can't join a proton with another proton because they would repel each other. The yellow are the neutrons, and they have the sockets built in to receive the protons. So to begin with, you would have a proton, single proton, maybe call it a hydrogen nuclei. You can add a neutron to it. Now you have deuterium. You could actually add another neutron to it. And then you would be able to add a second proton to form a helium nucleus. This is a 3D model that's used to illustrate mechanical advantage in gear trains. It has a small crank at one end that you can turn, and you can see the first gears turn fairly quickly, and by the time you get to the end of the train over here, you can hardly tell that it's moving at all. Now across these 5 gears, there's a 100-to-1 essentially reduction rate. The gears are all the same. They can come off, be easily disassembled by the student, and reassembled so they can understand how the gears interact and get a feeling for the mechanical advantage that's provided. Once you get several of these gears in the train, you can see how fast the end gear turns with just a slight movement of the first gear. So that's the Mechanical Advantage Gear Train lesson. What I have here are the platonic solids. Now, platonic solid is a solid which is a regular solid composed of a single face of a regular polygon. Same type used throughout. This is the icosahedron. There are 5 platonic solids: the tetrahedron, the octahedron, the cube, the icosahedron, and the dodecahedron. So I've gone through all of the different models that I've printed so far for 3D printed classroom aids, but don't worry, we'll be able to come up with a lot more in the future. So thanks for watching.